Alright, I want to make a quick video to kind of review on rational numbers. Just in case if anybody's having any trouble with rational numbers, which is probably a lot of you. Rational numbers. So if you even write the word rational numbers, and we'll pretend that it's like perfect handwriting. So the word rational. What other word is in the word rational? Ratio. Which, what does ratio mean? Think of it as like a fraction. So the first thing is, let's say if we're trying to figure out if number 4 is a rational number, I guess what you need to think of is try to think if you can make a division problem to equal 4. So the first thing that comes to mind for me would be 8 divided by 2. All right, which if you read that, it's also a fraction because 8 over 2. And 8 over 2 equals 4 because 8 divided by 2 is 4. I think I repeated myself, but I think you get it. But there's multiple examples for this one, 4. Another one would be 16 divided by 4. Because 16 divided by 4 equals 4. And also, this is basically a fraction or a ratio. All right. So thinking of another one, let's do another example. Let's do like 10. 10. So thinking of a ratio, or thinking of a division problem that equals 10, we can think of 20 divided by 2, which 20 divided by 2 becomes a fraction or a ratio. Another one we could do is 30 over 3, because 30 divided by 3 equals 10. I guess the main thing to remember here is that really a division problem is a fraction. So as long as that division problem equals the number that you are trying to figure out, if it's a rational number, which in this case is 10, if you can get a division problem to equal it, it is a rational number. So now let's make it just a little bit harder, assuming that maybe you got it. Let's do like 0.43. All right. So for 0.43, now one easy way is to, again, make this a fraction. And if you're thinking, what the heck, how am I going to make this a fraction? Well, think of it this way. This number is in the 10th place, and this one is in the 100th place. So to put it in a fraction, since it's in the 100th place, you can do 43 over 100. So 43 over 100, is that a division problem? Yeah, because if you put 43 divided by 100, you're going to get 0.43. So hopefully that is making sense. And to get another example, we'll do 0.33. All right. So again, this is the 10th place. This is the 100th place. So that tells you your denominator is automatically going to be 100. All right. So 33. You do 33. And there you go. That is one way you can figure out if it's a rational number. But it also reduces to 1/3, which is just another way for 0.33. All right. And remember, irrational numbers is the numbers that you can't put into a ratio. So like we said, if you remember when I was talking about the pi, how that number just goes on forever and ever and ever and ever and ever. Well, that is an irrational number. I'm not going to erase it. The heck with it. So yeah, it is irrational. Another example of irrational number is a non-perfect square. And if you remember, the square roots are basically the opposite of something that is squared. So if I'm asking what is the square root of 16, I'm thinking of two numbers multiplied by itself that equal 16, which in this case is 4, because 4 times 4 equals 16. So if you want to think of the next perfect square, I just found out what 4 squared is. So to find the next perfect square root, I would mess with 5. So 5 times 5 is 25. So the square root of 25 equals 5. It's kind of just working backwards, back and forth on each other. So a non-perfect square root would be, for an example, since this is 4 and this is 5, any number between like 16 and 25 is a non-perfect square root. So you could say negative, oops, that's a really bad square root. Negative 17 is irrational. Negative 18. Negative 21. Or not negative. The square root of 21, sorry. Square root of 21 is irrational. So yeah, hopefully that helps. And if you're still having trouble, let me know. I can try to think of simpler ways or whatever for y'all to help learn it. But anyway, I hope this helps. Let me know.